Good morning. Welcome to this lecture on command lines for basic data management and text processing. My name is Wimauki. So this is a two-part video. And in the first part, I'm going to introduce you to basic command line tools and the different use of the different tools for different purposes, and hopefully to give you a sense of how useful these tools are, and particularly how you can combine them together to be able to help you manage your data files and be able to look into and examine what is in the data, uh, and as a kind of an exploratory analysis. That would be the first part. And then the second part, I'm going to kind of combine all we have discussed here in an exercise or a demo, so to speak. And that demo will be focused on this Shakespeare's plays or writings. And so we'll be able to kind of look into that small data collection and use the command line tools to quickly generate some statistics about Shakespeare's writings and term statistics, and so we will be able to get some key insight right into that data set. So this is the first part on the lecture, and so let's get started with this. Now I will start to say that this presentation is is possible because of the assistance of ChatGPT. Because I have to say that for the exact code that I need for command lines, actually I often just go to ChatGPT and ask the exact command line with the exact parameters that I will need. So that is a great tool that people can use today, thanks to the advancement of AI. So, and I also encourage you to use it to assist you in all these tasks. You don't have to remember everything that I have discussed here, but you can go back to such tool to see, okay, how can I do this on command line? But let's get started with this lecture. And so first, what is a command line? And particular command lines are run in something like shells, right? So what is a shell? And so basically, a shell is a computer program with a command line interface where there's no graphics. So I mean graphics or graphical user interface GUI is something that we are so used to. But in command line, you do not have graphics. You only have text or maybe numbers, right? But that interface allows you to control your computer using commands entered with a keyboard. So in command line, basically, you do not use your mouse. You only use your keyboard as the input, and then in return, you get text or numbers, without any graphics, right, in the output. And that's it, right? That is the command line. So this, you compare this to the GUI interface with graphics and mouse clicks, which we are so used to today. But for those of you who have been with technology long enough, you probably remember in the old days, you will have, tools such as MS-DOS, things like that, right? And perhaps Unix command lines that you use to interact with the machines before the Windows, the notion of Windows, right, came along. So the evolution of command line interfaces from, for example, from the Microsoft side, from MS-DOS to Windows, and of course today with Windows 10 and 11, you have the PowerShell, right? You have the Windows subsystems or Linux, which are also capable of command line. So right now, the way to interact with these command line interfaces is through the PowerShell and also the Windows terminal. And then on the Linux side, we have Unix, Linux, and Mac OS, right? BSD is the version that Mac OS is rely on, and we have the notion of the application or the app, terminal app, that you can use to go back into the command line mode, right? And there are different shells. I'm not going to talk about them. There are subtle differences, in terms of how you actually run the commands, the exact command and parameters and the environmental settings. But this is not important in this lecture. We're going to focus on some of the key commands in this lecture and try to make sense of them, try to see, unpack what they are capable of, right, for our tasks in data science. And so if you use Mac OS or Linux, you simply use the terminal app. If you are on Windows 11, the best is to use Windows Terminal, in which case you have to enable the Windows subsystems for Linux. So if you can do that, you can replicate what I'm going to show you on the Mac OS or Linux. So the reason for command line is that because of the simple input and output from keyboard, you can script everything, right? Everything can be scripted, and so it can be easily replicated. Like whatever you have done to accomplish this task, right, is not by mouse clicks, which is hard to duplicate, right? But just by a sequence of commands and parameters that you enter. Okay, so that is the beauty of it. Now, in today's lecture, my focus is to help you do data pre-processing and maybe some level of exploratory data analysis without programming. Now, command line, you may think, oh, we need to put in lots of commands and program. The fact is that as long as you know each one of the commands and the parameters, you are not really doing very complex programming, right? So we're going to pick some of the popular commands that can help us with text processing and basic statistics. And then we are going to combine the power of all these different tools to do really useful tasks. And again, as I said, it doesn't require complex operations. Such as loop and if, else, if, all these different structures, which can be intimidating, right, for some of you who without programming experiences. And I'm going to provide some examples based on commands in the Mac or Mac OS or Linux environment. So now to start with, again, you need the shell, and so if you need to use the app, the terminal app from Mac and Linux, and also the terminal app on Windows. Okay, and so the prompt, when you load the command line environment, the first thing that you see is a prompt. Which is normally a dollar sign, but it can be different things depending on your privilege. If you are a system administrator or a regular user, the prompt can be different, but also depending on your setting, the prompt can be different. This is only a subtle thing, and so, but normally I use, dollar sign, for the prompt. Prompt is provided by the system as the starting point for you to enter something. So that is not something you need to type. Okay, so this is from the system. Sometimes it can be a more kind of informative prompt with the current working directory information as part of it. But I'm going to skip the kind of the detailed information and say, okay, the prompt is just a dollar sign. And then, for example, the head, the example that I show you here is what you enter into a command line to do something. And the basic syntax of a command is something like, okay, the name of the command. So you need to know which command you are using, followed by arguments, which normally comes with a dash or hyphen, and then the argument name and value and things like that. And then in the end, sometimes because the command may have to work on one file or multiple files, you may provide the name of the file, right? where the file is, what the name of the file is as input, right? So this is an example. So head space and then -1000 space big data.txt. This is to output the top 1000 lines in the big data file. Okay, so this is just a very, very simple example of a command line. Let's get into some specific commands for different tasks and different purposes. Now, the first thing I think you need to know, of course, is to navigate the files and directories, right? So you need to be able to see where you are. So pwd is to print the current working directory. CD is to change into a different directory. So if you have like subdirectories, right, you want to go into use CD, or if you want to go one level up to the parent directory, you can CD to go up as well. Now there's also the ls to list the contents of the current directory. So ls will show you all the files and subdirectories in this current working directory. Okay, so now just to show you some examples, pwd, right now if you are on the desktop directory, it will show you something like this. This is more of a Mac OS setting, right? Normally your username is under /users. Now, if you use ls, and depending on what files you have, you may have a couple of files in there and perhaps a subdirectory such as authors. Okay, and then at this point, if you want to go into authors, you can cd space authors to go in there. And then once you have done that and you use pwd, you're going to show the current directory, which is going to say you are under desktop/authors. Okay, and then you can use ls space -l, which is -l is a parameter for ls, which is to provide a kind of a long version of the list. So if you see the example above, it's just a very brief list of the names. If you use -l, it's going to show you more details about the files, whether they are directories or files, and how large the files are, and you know, when those files were modified or revised, things like that. Okay, so so that is basic navigation. Now you can also create and remove files or directories. Now touch will allow you to create a new file, such as touch new, right? That will create a new .txt here. Mkdir is to make a new directory, so mkdir appendix, right, is to make a appendix new directory. Okay, now to remove a file, you use rm, right? Rm space o.txt. Assuming o.txt has existed, then this is going to remove that file. So these are simple kind of data file management, if you will, right? To keep your file directory organized. Now let's get into some specific commands that can help us process, or even to start with, just to view your data. So cat is the most basic command to display the entire file. So let's say you have an article.txt, right? In the directory, you can use cat space article.txt. So it's taking article.txt as the input. Okay, it's going to read the content of the file and then present the file to the standard output by default. Now, what is standard output? The standard output, you know, in our today's context, is the screen. Okay, so screen is the standard output, and so that will show that on the screen in the terminal. Okay, so that is what cat will do. I already showed you an example of head, which is to go in to show, right, to display the top part of file. You can determine how many lines you are going to show at the top. There is also this tail, right? Tail, so conversely, is to show the bottom part of the file. So tail -50 article.txt is going to show the bottom 50, kind of the end, right? The 50 lines at the end of the article. Now, string translation, so tr can translate characters. So it has many different functions, but I just wanted to quickly show you this function to convert all uppercase to lowercase. Okay, so use tr uppercase to lowercase. This is one example. Now let's get into some kind of statistics. So think about your data science or data analytical workflow, right? Initially, you want to take a look at some data, use cat and head to be able to sample the top, bottom, and even the middle with a combination of head and tail. You should be able to look at the middle of the file. But now let's say you want to start to generate some basic statistics. And so the first thing, like, okay, I have a big collection of lots of articles in there. Could you tell me how many words and lines and characters and bytes are in there? So WC, for example, will be able to help you do that. So WC-L is going to count the number of lines in that file. So if you have a CSV, which is comma, delimited, separated values, it's a file that is commonly used for, for data analysis. You can use WC-L to count the number of records or lines in that CSV file, right? Now, if you want to count the number of words, for example, if you have the Shakespeare's collection in this Shakespeare.txt, you can use WC-M to count the number of words in that collection, right? So this can be quickly done. So you can count the number of words, number of lines, number of characters, and number of bytes. Okay, that is the WC command. Now, of course, just count is not going to give you everything. So sometimes you need to aggregate, right? You want to be able to aggregate and remove duplicates and perhaps perform some aggregation functions such as, okay, could you count the number of votes for me? So for the common question of, like, in the football world, Messi versus Ronaldo, right? Messi or CR7, right? So maybe there's a number of votes for Messi, there's a number of votes for CR7, and you try to count them. So suppose this is votes.txt has the original data, right? All the Messi votes and then CR7 votes, right? So now how do you count them, right? So obviously the real file can be much bigger, so it's not easy to count by hand. So let's say how we can use that command to count them. So the command to use is the uniq command. Okay, so so I need to really talk about this uniq command. So the uniq is to merge duplicates, and in the process of merge them, you can also ask it to count. Okay, count the number of duplicates basically. So the number of votes for Messi is the number of duplicates of Messi, right? CR7, the same thing. So what we do here is uniq space -c, and then the input file votes.txt. This will give you the count for Messi and the counts for Ronaldo or CR7. Okay, now the assumption here is that the votes are already sorted because uniq, it only works on a sorted list because it assumes the duplicates will appear together, okay, one next to another, and so it will work this way. If it's not sorted, then you will need a sorting tool. Unfortunately, the command line does offer a command called sort. Okay, so you can use sort, for example, to sort the names in the text file. Okay, and by default it will be in the alphabetical order. Okay, for names that works perfectly. Now for numbers, like let's say, okay, I have a number of scores and I want to sort the score to figure out what would be the highest score in this class and what is the lowest score, right? So you can use sort, but because they are numbers, the way to sort them is a little bit different. So you need to use this -n. Okay, n for number. And then what is this r? This r is another parameter to tell the program to sort in the reverse or the descending order. Okay, so if you want the highest score to appear at the top, then use r, right? So r is the reverse order. So NR will sort numbers in the reverse order. Okay, so that is sorting. Now let's talk about searching, right? So if you have a collection, let's say again Shakespeare's writing, and you really want to see, like, oh, I'm wondering which play or which part of Shakespeare's writing mentions Calpurnia, the wife of Caesar, right? So in this case, you can use this grep. So grep is a command to search and filter text lines. So if you use grep space and then what you want to search for, Calpurnia in this case, and then Shakespeare, the input file, right? It will be able to kind of get each text line in Shakespeare that contains the exact word of Calpurnia. There are more that you can do with grep, with the regular expression, which I will talk about at the end of this lecture. So it's a very powerful tool to search not just for exact matches, but also for patterns of matches. Okay, so but grep will allow you to search and filter. Now let's talk about something that is super important and super powerful. Okay, at the first glimpse, maybe it's something just ordinary, but let's talk about input, output, redirection, and pipes. So we need to understand the basic of input, output, and arrow. I'm not going to talk about arrow today actually, but I already talked about the output, right? The standard output when you use cat, right? So cat and then space in.txt is reading the content from in.txt as input, right, into the computer memory, and then show it, display, output, send that content to the standard output, which is the screen. And so you will be able to do that. But what if you don't want to show that to the standard output? You simply want to redirect the output to another place, such as to another file. You will be able to do that with this greater than symbol or this bracket, right? It points to a different direction. So cat in.txt and then bracket or less greater than out.txt. This will redirect the standard output, which is the display. Things that are supposed to be shown on the screen. Instead of showing them on the screen, you redirect them to a file. Okay, and so that content in in.txt will override what is in out.txt. So with one greater than symbol, you will overwrite everything in the output file. So that means if output file has already something in there, they'll be gone. Okay, everything will be new, totally overwritten. So there's a danger in here. Just be careful. If you have something important already in the out.txt, you do not want to do that. Okay, now a different approach here is that you can actually use double greater than symbols to append kind of to redirect and append the content to the end of the file. So let's say we already have a fellowship.txt with some fellows in there, right? And then I want to grab some new fellows and add to the existing list. And so let's say, okay, I grab data from, and I search for fellows in the more.txt, and then I will redirect the output with two greater than symbols. So with these two, this is to append. Okay, so the ones that you get from this command will be appended to the end of the fellowship.txt. So in this case, the existing data will still be there. There will simply just be more data, okay, at the end of this command. So that is the redirection from standard output to a file and to other places. And now let's talk about something even more powerful, okay? And you will know later when I give you some more examples. Okay, so pipe or piping with this, okay, vertical bar, basically vertical line. So what it does is that you can combine multiple commands with piping and allow the output of one command to be the input for another. And so that will enable a very useful combination of different tools together. And with piping, you are not limited to one output to as input to another, but you can continue to do it, so it can be a chain, right? So think about this. I can catch Shakespeare, and I know when I catch Shakespeare.txt, it's going to output all the content to the standard output. But instead of showing everything into the standard output, I'm going to pipe to my next command, which is to grab Caesar to search and filter the text line for Caesar. Okay, so the cat, okay, command, the output will become the input for grep. Okay, and then after this grep, I'm not done here. I continue to pipe, okay, to wc-l, which is to count. Okay, so what I essentially have done here is to output the content and then run a filter using grep to only retain or keep the text line with Caesar in it, right? And then that will be sent to this counter called wc-l, which we encountered earlier, to count the number of lines. So what this does is going to tell you the number of lines containing the word Caesar. Hope this makes sense. Now, so we are going to get into some more commands for text data processing. And these are very useful tools. And of course, this is just one lecture. I'm just going to give you a sense of what they are capable of doing. And there's a whole world of resources that you can look into regarding how to use them. But these are important tools for both data gathering and text processing, among others. So let's take a look at some of these. I think I moved too fast to okay, data gathering and communication commands. So wget is such a powerful tool for you to be able to fetch or download data from different sources. Okay, so if you have a web URL, right? Someone has posted data set of, I think this is for the Tiny Shakespeare's collection. Okay, so someone has posted that collection somewhere, data set. You can use wget and then followed by the URL to grab that data and save it to your working directory. So that's quick and easy, right? You don't need your browser, right? The other tool, which I'm not going to dive into, is the curl, okay, or curl. So that is a even more dynamic tool for you to get and to send data from or to server. So curl is, you can think of it more like a browser, okay? And where you can send data to a server and get data from it. You can actually do lots of communications both ways. But because today is just an introduction lecture, so I'm not going to get into all these. Okay, so but anyway, wget will allow you to fetch or download data from external sources. Now let's look at some more advanced text processing power tools. So one is awk, AWK. It's the pattern directed scanning and processing. So we already say that you can do do things with grep to search and filter, but awk will take this to another level, because awk allows you to do things both at the raw level, like text lines, but also at the column level. And especially if you have a kind of a delimited data set such as CSV, right? CSV is comma delimited, right? You have multiple fields or columns on each row, and that are delimited either by a comma or a tab or other special symbols. And so if your data can be separated into columns, awk is a great tool on the command line. So let's say yeah, I have a number of records, maybe student records, maybe other records, right, in there, and lots of them, and they are, they come with columns such as, okay, maybe the student name as the first column, student age, student gender, student, what program the student is in, and then, what year of the program they have advanced, things like that. So there are a bunch of fields, and so certainly you can use cat, right, to read the data and output it, and then you can pipe it, right. This is the piping mechanism we talked about earlier. You can pipe the output, which is the entire data set, to awk, okay, with this space dash f. This allows you to specify the delimiter. F is for the field separator, and then if you put comma, that's to say the separator, the symbol that separates columns, okay, is a comma. And then this is the actual script. In order for you to select specific columns, okay, from each row. So there's much more you can do in awk, but this is just a very simple example, okay, to print the column number one. So dollar number one is the first column, $3 is the second column, $5 is the fifth column. And so if you want to, if you have lots of columns and you want to single out the first, third, and fifth, you can do this quickly, okay? So that is awk. Another tool I want to discuss is Perl. Perl is actually a whole programming language. So is awk. But Perl is also a very mature programming language. And the advantage of Perl is really for text processing. So for many years, actually, people used it to create, web systems, to build search engines even. So Perl is a very powerful programming language. But what I'm going to focus here is the inline capability of Perl. Because yes, you can create a whole script file with Perl. But we are talking about command line. So let's see how we can use Perl with the inline command line. So with Perl PE, -PE, and E is actually for regular expression. So this is a really powerful tool. Combine the capability of Perl to process text data, but also regular expression to kind of find patterns and be able to substitute something with another. So let's take a look at example. So let's say you have an article, or maybe many articles, and you want to be able to revise certain terms that you have used in those articles, right? So I'm now part of Drexel's Computing and Informatics College of Computing and Informatics, which is referred to as CCI. But we used to call ourselves the iSchool at Drexel. And so if you want to, let's say the article has iSchool in it, and now we want to change everything iSchool to CCI, right? So we can use cat, right, to output the content and then pipe it to Perl with -PE, which is going to run a command to substitute or to replace, okay? And so you put quote unquote, and then this S is to substitute, okay? And then the first word or term or sequence of symbols after the slash is what you are searching for. So slash iSchool, I'm searching for iSchool, and then slash CCI, that iSchool will be replaced by CCI. Slash G is a modifier to say this is a global search, so it will search everything, okay? So this will do the replacement, okay? Hopefully this makes sense so far. Now, regular expression is a whole another lecture, but let me just be quick and brief about what it's capable of doing. So a regular expression is a sequence of symbols that forms a search pattern. Okay, symbols may include alphabets, numbers, and special characters. They can be used for text search and matching, or search and replacement or substitution. So let me give you an example. Actually, some more syntax before I offer you some example. So a search pattern is expressed by slash the pattern you are searching for slash modifiers. And different modifiers that you can use. We already use G. It's a global search. You will find all matches instead of the first match, right? I is for case insensitive match, right? So in case you don't really care about the case, whether it's I score capital or I score lowercase, you put an I as a modifier here, will allow you to search all the different forms, right? Lowercase or capital. And then M is for multiple line matching, okay? So normally when we use regular expression, it's matching one line at a time. But if you want to search across different lines, like a pattern really spans across multiple lines, that's where M should be used for, okay? If there's a connection between the different lines. So let me show you an example. So if you are searching for leading or capital, but you want to be able to match lowercase ones as well, what you can do is to put slash leading slash I. As again, I is a modifier, okay, which will make sure you will search both lowercase and capital forms. Now, a bit more about regular expression, okay, and we cannot be comprehensive today, but at least I'll give you something that to consider. So with regular expression, normally you are not looking for an exact match. You are most likely looking for some partial match with certain patterns. For example, a zip code, right? The US zip code is like 5 digits. And so if you're searching for five digits, there should be an expression of what is a digit, right? You should be able to say, okay, how can I express one digit? And so in regular expression, slash D is for one digit, okay? So to search for a zip code is something like slash D, and slash D, or for 5 times, you will be able to kind of create a pattern like that. Of course, there's actually a much efficient way to do that, but slash D is for digit, slash W is for word character in the alphabet, right? And then slash S is for white space. And then slash B is for a word boundary. So these are very useful if you are doing, language processing, right? Because you are really looking for words and word boundaries, things like that. And then there are some Unicode, capability. Like sometime for punctuation, this is something I will also kind of provide here because I'm going to use one in the demo, in the example. So punctuation, this will create a match. Now let me also talk about a dot. Okay, this is the wild card. A dot is for any single character, anything. Okay, whether it's the digit or character or punctuation or white space. Okay, anything. And so if you're really searching for something in the dot, like, okay, I'm searching for an email address, right? So that is something, and so in that case, because dot is a special character, so you need to use slash dot for actual period or dot. And so there's just one note there. Now, in regular expression, you can also express how many times this symbol or this part of the pattern should repeat. So for example, if you put a question mark after something, it says, I'm looking for either 0 or 1 occurrence. So that thing you're looking for may not occur or may occur only once. If you put a star after it, it's searching for 0 or more occurrences. So it may not appear, it may appear once or twice or more. Okay, that's when you put a asterisk. And then if you put a plus after it, that will guarantee to have at least one occurrence of the thing that you are looking for. Okay, so there are also more specific parameters that you can say to specify, in which you can say, I want 5 to 10 occurrences of this repeating. Okay, that's also doable. But because today, again, time, I don't want to kind of get into too much of the weeds. Now, there is also, when you are doing kind of search and substitute, right? Oftentimes, actually, you are going to preserve something or in the initial, in the original text. And so, in order to preserve what already is there, part of the matching, you need some reference to the match patterns. So let's say, okay, this is pattern number 1, pattern number 2, pattern number 3 in the sequence. And so if I express all these as a regular expression, I can put pattern 1, okay, the whole expression in parentheses, and pattern 2 in parentheses, and then so is the third pattern. Now, why do I want to do that? When you do it, the first set of parentheses, the whole thing can be referred to as the $1. And then this second part is referred to as the $2. Okay, the third is $3. Okay, so the purpose of this is that, okay, because of this, you will be able to preserve and discard or rearrange these. Maybe the order should be changed, right? Maybe you don't need pattern 2, you only want to preserve the number 1 and number 3. And so in that case, you can only say, okay, I want to preserve $1 and $3, and that's it. You can discard number 2, right? So this is the reference to the original matched sequence. Now, let me give you an example. Actually, I have an error here, which I think I can quickly fix, but just because something I said. I will talk about it. Okay, so let's say this is a regular expression in which you want to search for an email address and be able to tell, right? Change it into a different format. So let's say, okay, I'm searching for something like John, right, at drexel.edu, or perhaps another person that is, I think, something like maybe Matt, right, at another institute, maybe penn.edu, right? And so let's say you have an application, you simply just want to identify the account, right, from this email address as well as the domain name besides edu, right? So that you can change this John at drexel.edu to something like John from Drexel, and then Matt at penn.edu into Matt from Penn, right? So maybe this is the purpose, and so this is the regular expression that allows you to do that, right? So the first part here, assuming the account is all word characters, all alphabets, so you can use /w, right, for a word character, and then plus. Plus means at least one occurrence and can be multiple, right? So this will match something like John or Matt. And then if you put a parentheses, a set of parentheses here, this is the first pattern that you're searching for. So this is $1, okay? And then you have an at, which will match the one here, right? And then you have /w plus, which will match either Drexel or Penn, right? And then with the dot, which actually I should put a /dot, okay? So let me, it's a correction, so let me make sure it's correct, /dot, because we know a dot is, this is my problem, my fault. Okay, I should have put a slash here. So because dot is actually a wildcard, and so /dot will actually match a dot here, okay, and then .edu, and so we can single out the account name and then the domain name before edu. Okay, hope this makes sense. So let's go back to the slide. I have a few, and then I'll conclude this part of the lecture. So um, this is kind of a very brief introduction to some of the basic command lines, highly useful for basic data search, review, and exploratory analysis. In the next video that I'm going to create, we're going to focus on a case study for exploratory analysis of Shakespeare's play, Shakespeare's writings, to be downloaded from here. Okay, so it's already available there. And so what I will say here is that this data will have two files. And the first one is something that I will focus on, the Shakespeare underscore data.csv. It's actually a very structured data with columns such as, okay, the play, the section, right, the scene, and the player, and then the actual words, the line of that player. Okay, so it's kind of multiple column, so very structured format. Okay, so we'll be able to do some interesting analysis there, and then there's all lines.txt with all the just writings in there. Okay, so the first one is what we are going to focus on. So in this case study, these are the tasks that I'm going to kind of show you about. Okay, so the first task is to count the number of lines, number of plays, and even the number of lines per play. Okay, we'll also be able to identify a set of unique players in each play and be able to count them in those plays. Okay, so you will be able to have a count, but not just have a count, but counts that are aggregated for each play. So you will have some basic statistics about, you know, which play has more players in there. And then we'll also conduct some search, right, for plays that contain certain keywords, so that actually you will be able to create some kind of retrieval system based on that. Okay, what plays contain, for example, Brutus, right? And then lastly, we'll do some basic text processing and generate some term statistics. So there's an example. There's more we can do, and but one term statistic I'm going to show you is how can we generate term frequencies in the text. So the number of occurrences for each unique term, right? So with the command line tools that I have discussed, there's actually a very simple way to combine some of the tools together and be able to generate term statistics, like such as the word "the" appears 100 times, the word Brutus appears 5 times in the text, and things like that. So we'll be able to do that in the example. But in the end, I just want to kind of sum up this whole discussion of command lines with some remarks. So there are some shortcuts in command line, and you will see me doing kind of doing all these during the demo. One is that the history command allows you shows the list of used commands. Okay, so you can use history, type history, hit enter to see the commands that you have used. But you can also use this up and down button on your keyboard to go back and forth, and that basically allows you to go to a previous command that you can reuse and revise, right? There is also this tab completion, so you can type partial command name and tab to finish the command. Or maybe the file name. You're typing a command and then the input is a file, so you space the file name. Maybe the file name is long, so you don't have to type the entire name. So you can type the initial part of the name and tab. If there is only one choice, that file name will be given to you. If there are still multiple files with the same leading characters, it will show you a number of choices. Okay. And then there is also, like, when you go to a previous command line command that you have executed, maybe that command is long and you need to go back to the beginning of the command to revise it. So Control A will allow you to kind of quickly go to the very beginning, and then Control E will allow you to go to the very end of the command so that you can revise the command much more quickly. Okay. So anyway, so command line best practices, you know, it's always good to have good organization, okay, of the commands that you have used, and then also try to, because you will never know or remember every single command and every single argument as part of the command. So utilize the man page. So on command line, if you use man, which is more for manual, and then name of the command, it will bring up the whole description of how to use the command with parameters. Very detailed in there. Okay. And one last thing, actually, so quickly, we don't discuss this, but you know, sometimes you do need super user privilege to run certain commands, but unless you know what you are doing, you don't use this sudo, okay, unless you know exactly what it entails, okay, because it's super user, it, you can do anything, okay, or everything with that. So be careful with that part. But fortunately, I haven't really touched on that. Lastly, on best practices, in the age of large language models such as ChatGPT, I would encourage you to work with such tools because, among others, they are very efficient and accurate code generators. And so you can ask questions about how to do this and that on a command line. Ask ChatGPT among other tools. Okay, and part of this lecture, you know, I actually consulted ChatGPT for some of the specific commands and parameters. Okay, for the exercise actually. So in the end, know the commands and what they are good at, and then find a way to combine them. And the pipe, okay, or piping is a great friend. Okay, so work with your friend. And as for command line for data analysis, you know, always sample and test first, because if you have like terabytes of data, certainly you do not want to run a command line just test it right on the entire data set. So you want to take a sample and then test it with other commands. Make sure it works out and nicely before you apply that to a much greater data set, right? So sample and test before a run on the entire data set. That's my final word. So with that, I will conclude this lecture, and I will see you in the next one when we actually do the exercise and apply the tools that we have learned about to the Shakespeare's collection. We'll see you there. Bye for now.